Hey guys, here's you a short and sweet one for the next unit. So we're going to divide this next unit into probably 3 sections. This first section is an easy one. So here we go. This is all about climate. So sometimes we define climate as just simply the mathematical average of temperature or wind speed or humidity over a long period of time, but it's more than that. It's tracking the changes, the variations in all those aspects of weather over a period of time, and establishing what we call norms. Now the norms or the normals are the mathematical averages, but you can also track um, gradual changes and extreme changes. Um, that would also be considered climate. It has to generally be about a 30-year track for it to be considered climate. So if we took the temperature every day in the same city for 30 years, we could eventually establish climate for that area. Now that doesn't mean that the temperature is always going to be that temperature, whatever that average is, on that day of that year. For example, if we track the average temperature of Myrtle Beach, South Carolina in the middle of July 15th, and the average is 86 degrees, it is still possible, of course, to have a day that may be 100 degrees or in the 70s or even lower than that. So you can have extremes that go away from the climatic average. Climate is important not just for how you're going to dress, that also helps, but businesses and companies that are going to build factories and locate their businesses places, that they might also uh, determine where they're going to locate it based on the climate. For example, if you have a snowplow business, you're probably not going to locate in Florida. So older folks tend to, if they can move when they retire, they tend to move towards warmer climates, because it seems like the elderly like the warmer weather than they do the colder weather. So plenty of people escape the northern part of the United States and move towards Florida when they retire if they can afford it. So the mathematical average part of climate are called the normals. And you know, we collect data all over the globe every single day, sometimes every hour. And if you take all these numbers and crunch them together and get a mean or an average, then that would be a normal. But remember, normals are not perfect. You can have extreme situations that far exceed the normals on either end of the scale. What's the cause of climate? Got a question for you. Why is the daily average temperature for an entire year higher in Dallas, Texas than it is in Green Bay, Wisconsin? We'll answer that later. The amount of sun that reaches the earth is highly dependent upon the curve of the earth and where you are located on that that globe, that sphere called Earth. So latitude, north and those lines of north and south, are very important when determining climate. We already know, you already know, that as you get towards the North Pole or the South Pole, it becomes colder, and as you get towards the equator, it becomes warmer. We're going to explore that idea a little bit more in class and figure out where the rays of the sun are directly hitting and where are they hitting at a severe angle. I want to remind you that the tilt of the Earth is 23.5 degrees on its axis. And what that means is that 23.5 degrees north and south of the equator, those tend to be the warmest areas of the Earth, and those are called the tropics. Anything 23.5 to about 66.5 degrees north and south are the temperate zones, and these are zones that will have cold winters and warm summers and a spring and fall season. They really do have 4 distinct seasons, and that's where we live. So we live in a temperate zone. Above 66.5 north and below 66.5 south, all the way to the poles to 90 degrees, it tends to be cold, and this is why we call them the polar area, poles, polar area. So latitude, because of the tilt of the Earth, is a big cause of climate. Topography, or the lay of the land, the elevation of the land and surface features like water or land or mountains, those are all also causes of climate. So it turns out that higher areas, higher elevation areas, have climates similar to those places in the north. You can go to the Great Smoky Mountains in Tennessee and drive up to Clingman's Dome, which is 6,600 feet above sea level. You can do that in the middle of summer, and it might be as low as 60 degrees in temperature. So driving from Gatlinburg all the way up in elevation to Clingman's Dome is kind of like driving from Georgia to Canada. That's how the temperature is going to change on you because of elevation. Tall mountains also have what we call a windward side and a leeward side. The windward side is the side of the mountain that the wind hits first. The slope of the hill lifts the wind up, condensation occurs, rain occurs, and that side of the mountain is usually moist and warm and got lots of plant life and vegetation. And as the air mass moves over that tall mountain, the leeward side, since the air mass has already taken all the mountain's taken all the moisture out, the other side is extremely dry air. And this tends to cause what we call shadow deserts in the shadow of a mountain. So the other side, the leeward side, is typically dry. So one side of the mountain or another side of the mountain can have a distinctly different climate. Oceans and other large bodies of water. Water tends to lose heat slowly and gain heat slowly. So areas that are located near oceans tend to have warmer winters and cooler summers than the same areas of similar latitude that are not near large bodies of water. It's the water has an insulating effect and keeps the area either cooler in the summer or warmer in the winter, much more than, say, an inland area. And then finally, the last cause of climate is air masses themselves. We know that air masses affect our weather. Air masses and where they intersect, the fronts, those affect our weather tremendously. And it turns out, this is kind of like a common sense or a duh thing, but it turns out that air masses that form over a certain area have those characteristics of that area. So if you have say a tropical Atlantic island, say down in the Caribbean or somewhere, it's going to probably be maritime tropical, warm and moist, and the air masses that it forms are also going to be very similar to that, warm and moist. So air masses can also have an effect on climate. So that's the end. Hope you enjoy the rest of your weekend and your day off tomorrow. See ya.